Welcome to the third section of the course. In this section, we are going to learn the concepts of convolutional neural networks. We will talk about a technique called dropout and how to apply it. We will build a basic convolutional neural network model and then gradually improve it. In the end, we are going to learn about transfer learning, or how to use the power of the very complex, state-of-the-art, pre-trained convolutional neural network models in our projects. In this video, we will see some of the applications of convolutional neural networks and learn how they work. The most popular application of convolutional neural networks is computer vision and image classification, but they are also used in many other domains as well. Voice user interfaces, deep reinforcement learning for game playing. What this means is that an agent learns to play a game only given access to the screen and controls of the game. Style transfer. The network learns to take a style from a painting and apply it to a provided picture. Links will be provided in the supporting materials so you can read more on these fascinating applications of convolutional neural networks. You can even provide the style transfer network a custom picture and see it in action. Convolutional neural networks are similar to ordinary neural networks. They are made up of neurons that have learnable weights and biases. Each neuron receives some inputs, performs a multiplication, and usually follows it with a nonlinear activation function. However, convolutional neural network architectures are built specifically for images, which allows us to encode certain properties into the architecture. This makes the network more efficient to implement and vastly reduces the amount of learnable parameters and thus computational complexity. Since convolutional neural networks are built for images, let's take a quick look at how a computer can interpret an image. For a computer, images are just a matrix of pixels. If the image is grayscale, it has just one value between 0 and 255 for every pixel. If the image is RGB, it has 3 channels with a value for each color: red, green, and blue. So, what a convolutional neural network does is to look at small parts of the image and search for patterns. Then, with each layer, it tries to combine these patterns into more complex features. For example, this is what the first 3 layers of a convolutional neural network that looks at a human face could see. The first layer finds lines and curves. The second one combines them in face parts like eyes or a nose. And the third sees the whole face. So, let's look at how this works. We have a filter that moves through our images and learns to search for a concrete pattern. Actually, we have many such filters, and each one learns different weights. Therefore, they learn to look for different features. Then the deeper layers learn to combine these features into more complex ones. Don't worry if this sounds too complex now. It will start making sense very soon.